So in our last video, we were discussing third-degree polynomials, which are called cubics, and then we also looked at this fourth-degree polynomial a little bit and graphed it and talked about what the shape of fourth-degree polynomials are in general. And now it's time to find these x-intercepts and find all the local maximum and minimum points of the given function. So we've got a reasonable picture. Alright, so here is a reasonable picture. I think I'm still going to work on this a little bit more. I want to increase my y-min and y-max just so I can see more of the function. So let's go, now we're kind of making big jumps here because, well, this function is very tall. So I'm going to go to, let's try 25,000. Okay, so as you can see, it's kind of difficult to get the whole variety of the picture in there. It would also help if we could see more on the left-hand side. So why don't we zoom it, go in that direction a little bit. Eventually, we'll get to actually calculating some stuff here. All right, I think that's doable. We can start with the intercepts. Now, as you can see, there are 4 of these. Four x-intercepts. I'm just going to, and here you can see the problem with this graph. Even though we can see what's happening, when you start trying to operate with it, all of your text is down here and it kind of obscures your vision. So we really, I hate to keep doing this, but we really still need more, we need to go down further. So I'm going to go ahead and go down to 10,000. And you can see kind of like how little difference that made, but it might be enough for us to work with. So let's try to find the 0. Yeah, I think that'll do. Okay, so let's find the leftmost 0 for this particular function. So now I'm on the left of it. That'll work as my left bound. Then we can go to the right of it. That'll work as my right bound. And then my guess is right there. And we get a nice integer value, -5. So our first 0 is at -5. And then we have 3 more. Now if you understood that process, you just repeat it 3 more times. I'm not going to go find all 4 of them, but you do need to make sure that you can find any of these. Okay. And again, for the local maximums and minimums, it's essentially the same process. So if I want to find, say, this maximum, that is a maximum, by the way, what I was just pointing at. It's a little one, but it's right there. Locally, it's the biggest fish in that little pond. So I'm going to find its left bound and right bound, and take a guess at its max, and the calculator says it's -3.94, comma 1578.8. Okay, so we have another max over here and then 1 local minimum. So 2 local maxes and 1 local minimum. This particular function actually has an absolute max, and whatever that one is right there, that high value there. Okay, so I'm kind of only halfway doing this problem. I did not find all of the intercepts or maxes and mins, but I hope you understand the idea. Here's all of the zeros and maxes and mins calculated, so you should check and make sure that you can find these values. Some general description. Now, I want you to keep in mind we are talking about a 4th degree polynomial. This fourth degree polynomial, its domain is all real numbers. Its range, remember what it looked like. It looked like that, basically. So its range is negative infinity up to that peak right there, that y coordinate, which was, we didn't actually find it, but that's the maximum right there. Okay. Now, because we have more turning points, we have more increasing and decreasing intervals. So you see that reflected here. It's increasing from here to here, increasing again from here to here, and decreasing from here to here and from here to here. So basically we have 2 intervals of increase and 2 intervals of decrease. And they fall around the turning points, the local maxes and mins. We also have more concavity. We have, let me draw a slide. Well, actually, let me just go back to the graph. We have an inflection point here and an inflection point here. So if you couldn't tell what I was gesturing at, we would have an inflection point in this area, and we would again have an inflection point over here. Now this is just a rough estimate. I know it's somewhere in here, and I know it's somewhere in here, and that's just because I know, well, I know what these changes in concavity look like, and so over here I know that we're concave down, but then in this area I'm concave up, so I must have an inflection point somewhere in here, and similarly over here. Now, if I actually want to find the coordinates of those inflection points, that's a little bit more involved of a process. And, oops, that's the wrong document. We haven't actually talked about that, finding inflection points. Okay.